We'll proceed in pseudo calculus problems. Okay, what problem by problem? Idea was that we will take problem by problem, but anyhow, looks like that still the calculation of the area of the circle is still the problem. Anyway, if someone is watching our past videos, last video, we have talked about that how we can do a repeated summation when we calculate the area of a circle. Area of a circle can be computed through repeated addition. Okay, so if area of a circle, okay, so when we see the area of a circle, so this is a circle. If this is a circle, then what is the area of the circle? Okay, if this is the circle, then what is the area of the circle? Then area of the circle is nothing but, consider, okay, consider this is x-axis and this is y-axis. This is x-axis and this is y-axis. In that fashion, I have a radius. I have a radius that, consider this is origin. Okay, if this is the origin, then I have a radius, and radius goes like this. Okay, then we divide when radius moves like this. How much radius moves? Radius moves 360 degrees. So radius starts from here, and it moved complete 180 and then 360 degrees. Consider that we divide into many sections. Area as repeated addition, and that is what we are pursuing now. Now consider that this is the radius. This is the first section. Then hope, consider this. So this is the first section, and this is second section. This is third section. In that fashion, this is fourth section. Like that, we divide the circle into many sections, where two side is straight line and end it is an arc. Okay, if I calculate section 1 area, section 2 area, section 3 area, like that, all the sections, add it, it will give the area of the circle. How much it is? Summation sign, summation sign, I believe it is sigma sign. I equal to 1 to n, and then a, and subscript, bottom right subscript, I, ai. If I do like this, it gives the area of the circle. What is this is a ith area, summation of I equal to 1 to n, a, I. If I know ith area, like that, if I change I to 1 to n, if I sum it, then I get the full area. Okay, very nice. Thank you very much. But what is the area of the ith section? Then we generalize it. The area of the ith section for the circle, what we have determined is that, I'm sorry. This is radius, this is radius, this is arc, and this is the ith section. From the x-axis, it is making theta angle. From the x-axis, it is making theta angle. Okay, and this angle is delta theta. This is theta angle, and this angle is delta theta I. Ith section, delta we provide when if I need some duration, some period. So this full is delta theta I. This is ith section of the area. In that fashion, if delta theta is very small, then I consider this arc as a straight line. If it is a straight line, then this line will fall exactly perpendicular on this radius. If I take it out, then this forms a triangle. This forms a triangle. This side, and this side. It forms a triangle. Area of triangle is half of the area of rectangle made by two sides. This is R and this is R delta theta I. In that fashion, this ith section area is 1 by 2 R into R delta theta I. 1 by 2 R square delta theta I. Okay, someone would say that why you are considering the circle radius at center. Radius can be here also. like r equal to cos theta. There is a function called r equal to cos theta. Radius would always start from the origin. That is guaranteed. So if this is a circle and origin is here, if this is the circle and origin is here, then radius will go like this. Okay, if this is circle and consider origin is here, if this is the circle and origin is here, then radius would go like this. Makes sense? In that fashion, radius will be functional. No. This is not possible. How radius can start from here? This is origin and this is circle. Agreed. Origin is here and this is the circle. Agreed. Shifted circle. In that fashion, how I can move radius like this? Radius is changing. If someone sees here, radius is full diameter of the circle, but radius starts changing when it is 90 degree. 90 degree radius is coming to full zero. Means radius is function over theta. If radius is function over theta, then what is the area of the ith section? Summation I equal to 1 to n a I. That is the area we are talking about. That is the ith section area. And ith section area, we have said it is 1 by 2, 1 by 2 r square delta theta I, where delta theta I is the angle of the ith section. 1 by 2 r square delta theta I is the angle of the ith section. Okay, if that is true, then area is 1 by 2 r square delta theta I is 1 to n. But if radius is variable with the angle, if I take delta theta I angle, if I take delta theta I angle and arc, if I take delta theta I angle and arc, then this is right. Consider this is radius. If this is radius, then this is radius is not same as this because it is function over theta. If at this point radius from x-axis angle is theta and radius is r1, then after moving delta theta I, radius will go down, radius will decrease. In that fashion, how much it holds? Consider it holds because delta theta I is very small. Still, we can consider this line falls perpendicular on this line. In that fashion, this AI area is R2 1 by 2 R2 into R1 delta theta I. R1 delta theta I is this arc R. Then I consider a straight line and into R2. No. Too much approximation is going on. Still, we do like this only. So the area is summation I equal to 1 to n 1 by 2 R2, that is the second radius, into R1 delta theta I, that is the arc, consider a straight line. If these two radius are function over theta, so R2 I can write function over theta and R1 I can write function over theta. Now it becomes I equal to 1 to n 1 by 2 function over theta into function over theta into delta theta I. 1 by 2 function over theta whole square delta theta I. Okay, this is perfect condition for converting into integration. That is integration sign 1 by 2 function over theta whole square d theta. Delta theta I will become d theta. Okay, so what is the area of the circle? Area of the circle is integration 1 by 2 function over theta whole square, that is the radius, function over theta whole square d theta. No. Okay, what is function over theta for you is r, right? So 1 by 2 r square d theta or 1 by 2 function over theta whole square d theta. No, I don't agree. Too much approximation is going on. How I can say that area, ith area, if this is the circle and this is x-axis, I start making section, first section, second section, third section, and then ith section. If this is the ith section, how I agree the area of the ith section is if this is radius 1 and this is radius 2, this is delta theta I. How I agree that it is 1 by 2 r1 into r2 delta theta I. If r1 and r2 are same, then I can consider that I can take this arc as a straight line and the length of this straight line will be r into delta theta I. If r is decreasing with the theta, then how I consider this length? This length is r into delta theta I. I agree. But how this length is also r into delta theta I? Both are different. This is this length. This is this length. Both are not same. How I consider? Consider. No, not possible. Okay, we cannot go to up to that much approximation. That is not possible. Okay, then what is the scenario now? Okay, prove it. Okay, through the repeated summation, we have brought in the area of the circle is 1. Integration sign 1 by 2. Integration sign 1 by 2. Function over theta, that is radius whole square d theta. Can you bring from other way? Okay, we will try through other way. Okay, what is other way? What is the circle area of the circle? That is under consideration. What is area of the circle? Okay, consider area of this circle. Area of the circle is in xy plane. Area of the circle is in xy plane. Consider there is another plane called r theta plane. This is xy plane. This is r theta plane. If it is r theta plane, then this is theta and this is r axis. This is theta and this is r. In xy plane, this is x and this is y. Both are at 90 degree to each other. Theta and r, they are orthogonal at 90 degree to each other. X and y, they are orthogonal, they are at 90 degree to each other. In that fashion, if I draw a circle in xy plane, circle is like this. Makes sense? Circle is like this, shifted circle, where this is the origin. Or circle can be like this, then it is centered at the origin. Okay, in r theta plane, if I have a rectangle, then this rectangle will map into xy plane as a circle centered at the origin. Okay, in r theta plane, if I have a r function over theta, then it will be mapped to a circle, shifted circle. What is your function? Tell me. Okay, function consider r equal to cos theta. Repeatedly we are saying this. Consider r equal to cos theta is the function. R equal to cos theta. If r equal to cos theta is a function in r theta plane, accordingly there will be a circle in xy plane that will be a shifted circle. If it is r and theta are independent to each other in theta r plane, it makes a rectangle over there. That rectangle would match here circle centered at the origin. If r equal to cos theta, this will be the circle. If r and theta are independent to each other, then this will be the circle, whatever it is. Okay, now please disclose what is relationship between xy plane and r theta plane. X equal to r cos theta and y equal to r sin theta. That is the relationship. With that relationship, a rectangle in theta r plane maps to a circle centered at the origin, or r equal to cos theta in theta r plane maps to a circle that is a shifted circle. This circle is at radius center is at 1 by 2 comma 0 and radius is 1 by 2. Okay, now idea is to calculate the area of the circle through the other philosophy, not repeated addition. What is the other philosophy? Philosophy in past video we took. Consider there is any point P here. There is any point P here and that point is x comma y. Okay. Now correspondingly there will be, okay, anyway, we will reiterate what we have left. So consider there is any point P here on the circle. This circle can be centered here. Circle can be, I'm sorry, the origin of this xy plane, this is xy plane, and this is the circle. Origin of xy plane can be here, it can be here also. Anywhere someone can take. If origin someone takes here, consider there is a point here called x comma, I'm sorry, point anywhere on the surface is x comma y, then this will be position vector. If someone draw the position vector, or if this is the center, then this will be the position vector. Consider there is any point here x comma y. Okay, now this I can represent it as a position vector. What is your position vector? Position vector is xi plus yj for the point x comma y. Now question is arising, how much this position vector would change if I change 1 unit of area in r theta plane. Makes sense? Earlier we had talked that if I take any point P here on circumference and this point P makes this point P makes angle theta with the x-axis. This is x-axis and with x-axis there is a line and it makes angle theta. Okay, if that is the case, this point is x comma y. This is position vector P xi plus yj. If I move 1 unit of angle, 1 unit can be picometer, nanometer, whatever, nano, radian, picoradian, whatever it is. If I move 1 unit, then 1 unit of angle, then how much this point would change? Earlier the point is x comma y. New point will be x1 comma y1 if I make 1 unit of change. In that fashion, on the circumference, how much distance it moved? Okay, distance that it moved is x1 minus x whole square plus y1 minus y whole square root. That much it changed. Or if first is vector p and another is vector p1, then p1 minus p magnitude. That much it changed if I change the 1 unit of radian angle. Okay, if I make 1 unit of angle change, then it moves P1 minus P, that I can say it as a delta P. P1 minus P, I can write a delta P, where P is a vector, delta P. Subtracting two vector will give another vector that will pass through the both points, that is x comma y, x comma y, and x1 comma y1. Magnitude calculating will give the distance between x comma y and y1 comma x1 comma y1. So delta P change in the position vector is delta P magnitude. That is the actual length that we see that move along the circumference if I move angle 1 degree. Okay, anything delta P vector magnitude, then length of the delta P with 1 unit change in theta. This is exact definition of differentiation. Per unit change in denominator brings how many unit change in numerator? Then it can be rewritten as dp by d theta. Same, dp by d theta absolute means magnitude of this vector. If p is vector, then dp will be vector. dp by d theta will be vector. Magnitude of it will give 1 unit of radian if I move how much the distance it travel along the circumference. dp by d theta magnitude. Now we were trying to calculate the what is the circumference of the ith section. If I divide circle into many sections, then how much circumference is the, if angle is delta theta multiplied by delta theta with 1 unit of angle movement, there is the delta p change, magnitude of delta p. Then if there is delta theta I radian change, then how much is the circumference of the I section? Then it will become dp by d theta magnitude delta theta I summation I equal to 1 to n will give the full circumference. In similar fashion, if I have a circuit and there is a point here called x comma y, and from origin I draw a position vector. Okay, if I make 1 unit of area change, earlier it was angle change, that was theta. Now if I make, because we are talking about area now, if I make 1 unit of area change, what is your area? 1 unit of area, or 1 unit of area, that is true. But area comes into the picture when there are two sides of, then only area comes into the picture. Consider the two sides, one side is r and one side is theta. Theta and r are two sides of one area, and they are at one position sometime. Then there is one, like theta. Right now we have at theta, and then I make 1 unit of radian change. Similarly, there is a point called theta comma r, and there is a 1 unit of area change. If there is 1 unit of area change, then how much p will change? Where your p is? P is a point that is x comma y. Okay, consider it moved. If theta comma r moved 1 unit, what is 1 unit? 1 unit you are talking. 1 unit is change. Consider theta comma r in a plane. There is a point called theta comma r, and theta moved 1 unit and r moved 1 unit. There is a unit change 1 by 1, that is 1. Now it is understandable. The other point on top right, if this is theta, then this is theta plus 1. If this is theta comma r, then this is r plus 1. This point, top right corner point, is theta plus 1 comma r plus 1. Delta, the change I see, change is 1 unit. If I make 1 unit of delta area change, then how much area change I see in xy plane? In xy plane, I have a point here x comma y. So suppose it moved to new point called x1 called comma y1. Then again it makes an area. This point is x comma y. Another point is x1 comma y1. This happened because there is a 1 unit theta and r change. Now I can connect this is x1 comma y1 and this is x comma y. It makes a rectangle. It makes an area. How much area change I see in xy plane? How much x comma y moved? How much area I see in xy plane if there is 1 unit of change in theta r plane? dp by d theta r magnitude. dp by d theta r will give the area vector, not the area. Change in area vector. dp by d theta r magnitude will give the net area I see change when there is 1 unit of area change in theta r multiplied by the area that is formed by the ith section, because we are talking about what is the ith section area. Makes sense? What is the ith section area? Ith section has angle delta theta I and radius delta r. Where is your delta r? Delta theta I understand that you divided the circle into many sections and each section is area. This is the ith area where this is the first radius and this is the smaller is the second radius. This angle is delta theta I. It makes delta theta angle with the x-axis. This is delta theta I, understandable. What is your delta r? This is r1, this is r2. Minus is delta r. R is changing delta r fashion and angle is changing delta theta. If this multiplication is 1, consider in this fashion in halo manner. In that fashion, if there is a 1 unit of area change, then r, if I move this r, earlier the r is like this, I move this r in a fashion that it decreased to a level. It decreased to a level. How much it decreased? It decreased 1 unit. And then angle also moved 1 unit of radian and 1 unit of whatever it is. If I multiply these two, it becomes 1 only. In that fashion, how much your position vector is changing? Position vector is x comma y. Now it is x1 comma y1. It forms an area. Consider this is a diagonal of one section. One point is here and one point is here. It forms an area. How much area it change because of 1 unit area I change, that is dp by d theta r magnitude. How much area change if I really move delta theta I rather than 1 unit into delta theta I delta r, r2 minus r1. This is the area of the ith section, dp by d theta r magnitude into delta theta I delta theta r. Okay, delta theta I delta theta r we will see. Right now we have dp by d theta r magnitude. This expression we have to settle it down. Okay, anyway, this I believe we left at this position only. Anyway, now consider that this is theta r plane. Up. This is xy plane. This is xy plane. Up. This is x-axis and this is y-axis. Okay, I try to make y-axis longer. This is x-axis, this is y-axis. This is theta r plane. This is theta and this is r plane. Consider in theta r plane there is a point called theta comma r. If I map theta comma r into xy plane, then it will map then okay. What is theta comma? In theta comma r, consider theta is function of r. I'm sorry, r is function of theta. We have taken one example as r equal to cos theta, not necessarily. R equal to sin theta, r equal to cos theta plus sin theta, r equal to 1 plus cos theta, r equal to 1 plus b cos theta, where b is constant. I can take 1, half, 2, 3, 4, 5. So many things we can take. In that fashion, consider that there is a graph here at where r is function over theta, or there is a graph here where r is not a function over theta. Whatever it is, if r is not a function over theta, then there will be a rectangle here. If r is function over theta, then depending upon the function, whatever it is, the mapping between theta r plane and xy plane is x equal to r cos theta, y equal to r sin theta. In that fashion, take any point theta comma r, theta comma r. Now from this point, I move theta. Okay, take in theta r plane, take theta r plane, take any point as theta comma r. move along theta axis 1, then r is constant, because if I move along theta, r is constant. If I move along r, then theta is constant. So here this point will be theta plus 1 comma r. This point will be theta comma r plus 1. This is 1 unit of area change we are talking here. It will make 1 unit of area change, dp by d theta r, into how much? Into delta theta I delta theta r. Now consider this point is theta comma r. Theta comma r, I move delta theta. I move delta theta along the theta axis. New point is theta plus delta theta comma r. Similarly, I move delta r along the r axis. Point is theta comma r plus delta r. The diagonal point will be theta plus delta theta comma r plus delta r. Makes sense? Now in that fashion, we have along the theta angle r is constant, and along theta axis r is constant, along r axis theta is constant. Now area here, I made a chain area here, that is delta theta delta r. Now correspondingly, I have a point here x comma y. Makes sense? X comma y. Now if I move theta keeping r constant, another point is theta plus delta theta comma r. Similarly, I move here point from x comma y to another point, and that point corresponds to theta plus delta theta comma r. Consider this point is x comma y. X is a function over r and theta, and y is function over r and theta. X equal to r cos theta, or I can say x equal to g bracket theta comma r. X is function over theta comma r. Y is function over theta comma r. X equal to g function theta comma r. Y equal to h bracket theta comma r. They are function over theta comma r. If there is a point here theta comma r in theta r plane, correspondingly there is a point here x comma y. Okay, this is g theta comma r comma h theta comma r, because it is function over x and y, function over theta and y. If I move here theta comma r to delta theta plus delta theta comma r, here another point come here as that is g theta comma theta plus delta theta comma r h theta plus delta theta comma r. Similarly, there will be another point here, that is g theta comma r plus delta r h theta comma r plus delta r. This is the one line, this is another line. One line is g or x comma y, g theta comma r comma h theta comma r. One is x and one is y. Another point is g theta plus delta theta comma r comma h theta plus delta theta comma r. This is the one line. Consider this line is P1. Okay, if I subtract these 2 points, it will form a vector, and this vector is P1. P1 is g theta plus delta theta comma r minus g theta comma r I plus g plus h theta plus delta theta comma r minus h theta comma r j. That is the vector. This is p vector, p1 vector. This consider this vector is a vector. This point is p, this point is p1 p vector, or p1 p vector. Another point is p2 p vector. What is p2? P vector, p2 minus p, that is p2 p vector. That is g theta comma r plus delta r minus g theta comma r I plus g theta plus h theta comma r plus delta r minus theta minus h. What is p2p? G theta comma r plus delta r minus g theta comma r I plus h theta comma r plus delta r minus h theta comma r j. If I do cross product of these two, because they may not be a straight line, perpendicular line, because there is a mapping here, depend upon the mapping function. But if this is a line and this is a line, P1P is a vector and P2P is a vector. If I take cross product of these two vectors, it will give me the area here. Means if there is an area change delta theta delta r in theta r plane, it brings area change in xy plane as P1P vector cross product with P2P vector magnitude. Okay, So how much it is? How much it is? Okay, this area, this is exactly what we are talking about dp by d theta r. We are talking about earlier dp by d theta r. If there is one unit change in the theta r, how many unit change I see in p? So dp by d theta r is this is what we are talking now. Delta theta delta r by d theta r, I can write it as delta theta into delta r. D theta r means how much is the area change. Okay, so I can write is that anything dp by d theta r, I can write anything. In d theta r, I can write 1, I can write delta theta delta r, I can write anything. Accordingly, I have to make sure that numerator is accordingly like that. If I write it 1, d theta r means delta theta delta r is 1. The area change in theta r plane is 1. Then I have to settle down the numerator like that only. But right now I have made delta theta delta r area change in there. In that fashion, I have to write delta theta delta r here. And numerator, I have to see what is the area there. That is dp by d theta r. We keep on talking. And then magnitude. Numerator is p1p vector cross product p2p vector. What is p1p vector? P1p vector is g theta plus delta theta comma r minus g theta comma r. Makes sense? I plus h theta plus delta theta comma r minus h theta comma r j. Makes sense? Cross product with p2p vector g theta comma r plus delta r minus, I'm sorry, g theta r plus delta r minus g theta comma r I vector plus g theta comma uh, h theta comma r plus delta r minus h theta comma r j vector. Okay, if I do cross product of these two, divide by delta theta delta r, this is dp by d theta r. In that fashion, now I can take cross product and divide and make it in two parts. First part is d p1p by delta theta, because multiplication I can keep in two sides. D p1 by p, d of position vector, d of vector p1p by d delta theta. Cross product d p2p by delta r. Theta is this side, r this side. Now what is p1p vector or delta p vector? What is p1p vector? This is g theta plus delta theta comma r minus g theta comma r I vector x-axis plus h theta plus delta theta comma r minus h theta comma r j by delta theta. This is exactly d d d dg. D is a function, right? dg theta comma r by d theta I plus dh theta comma r by d theta j. Cross product dg dg theta comma r by dr I plus dh theta comma r by dr j. Means at the end we received a vector in that fashion. Okay, what is d g theta comma r I d d of g theta comma r I plus s theta comma r j by d theta. This is g theta comma r is x and s theta comma r is y. It becomes d of xi plus yj or d of position vector. Initially we had taken x comma y as p vector. dp by d theta cross, similarly it will become dp by dr. Means dp by d theta r, that we had started an assumption that resolved into dp by d theta cross dp by dr. But make sure that in dp by d theta actually hidden is p1p vector, p1p, and dp by dr hidden is p2p, where in first dp by d theta r is constant. Make sure, because dp by d theta arise when I move, this is theta comma r and this is x comma y, and relationship is this is theta r plane, this is xy. This explanation is not there in any of the book. Till here it is there. What I said, it is there. Beyond this it is not there in the book. If this is theta r plane and this is theta comma r, this is xy plane and this is x comma y. In that fashion, from theta comma r I move theta plus delta theta comma r, and theta comma r I moved theta comma r plus delta r. In this movement r is constant, in this moment theta is constant. Similarly, this is x comma y corresponding to theta comma r. If I move, this point is p, if I move p to p1 corresponding to change in theta, in this moment theta is constant, and in this moment, I'm sorry, in this moment r is constant, in this moment theta is constant. Here in this moment r is constant, in this moment theta is constant. dp by d theta, that is p1 minus p, this vector, here r is constant. dp by dr, p to p, here theta is constant, make sure. Okay, magnitude d theta, d delta theta I, delta theta r. Okay, someone can now settle it down in summation if someone wants. The summation of I equal to 1. Now it makes sense. There is no assumption here, zero assumption. Summation I equal to 1 to n, and then dp by d theta or dp by delta theta I cross dp by delta theta r, or delta p by delta theta I, delta pi by delta theta I, cross product delta pi by delta ri, magnitude delta theta I delta ri of the ith section of the circle. Though this is not straightforward, no one can assume that area of the ith section of the circle is this much, but this is how it came through the vector. Someone can believe it or not, but this is perfect. Now I can turn into calculus. Now integration sign dp by d theta cross dp by dr, magnitude delta theta I delta theta I delta ri will become d theta dr as per the summation we have talked. dp by d theta r, magnitude d theta dr. Okay, what is dp by d theta cross dp by dr in term of circle? Consider x equal to r cos theta. What consider? It is there. So d of x d of dp by d theta, d of xi plus yj by d theta. So d of xi plus yj by dr. X is r cos theta, y is r sin theta by d theta, where r is constant. In that fashion, it will become r minus sin theta I plus r cos theta j by d theta. R cos theta I plus r sin theta j, that is xi plus yj by d theta, where r is constant. R minus sin theta I plus r cos theta j, cross product dp by dr, theta is constant. In that fashion, it will become cos theta I plus sin theta j. R will be differentiated. Cross product of r minus sin theta I plus r cos theta j, cross product, and then cos theta I plus sin theta j. We will do it. R, I and I cross product, I cannot take I and j cross product, I'll take, and it will become k. Okay, I and j cross product, it will become k, and here r minus sin theta, and there it is sin theta. R, minus r sine square theta. Similarly, here j cross I will be minus k, and here it is r cos theta, and here it is cos theta. Minus r cos square theta, it will become minus r sine square theta plus cos square theta, minus r magnitude minus r k vector, magnitude r d theta dr, r dr d theta, that will become r square by 2 d theta, where r is function over theta. But still in cross product, one side, this will, no one will tell like this. Okay, then in that fashion it became 1 by 2 r square d theta. Okay, r dr d theta 1 by 2 r square d theta. It is exactly same what we started with the assumption of the ith section, 1 by summation of I equal to 1 to n 1 by 2 function over theta whole square delta theta I or d theta. Here also it came as integration of the theta 1 by 2 r square or function over theta whole square d theta. Exactly same. Means we can, if our assumptions are true, then we can proceed calculating the integration through repeated summation also. What would be the result if I talk function r is function over theta? Then radius goes 0 to 90 degree and then back 90 to pi at 180 degree, because after that r equal to cos theta, after 90 degree r will become negative. Then I make opposite side, R will become positive, and then pi. 0 to pi angle would move. 0 to pi 1 by 2 function over theta, that is cos theta, cos square theta d theta. Cos square theta is theta by 2 plus sine 2 theta by 4, 0 to pi. That will be pi by 2 into 1 by 2. Pi is the area I'm sorry. It will be 1 by 2, 1 by 2 function over theta, that is cos theta, cos square theta d theta. Cos square theta d theta is theta by 2 minus plus sine 2 theta by 4. Theta is 0 to pi. Pi by 2. Pi by 2 into 1 by 2. Pi by 4 is the area, certainly. If I draw r equal to cos theta in xy plane, it will be a circle of radius half, and it will be not centered at the origin, shifted circle of radius half. That is pi r square, pi into 1 by 2 whole square, pi by 4. Okay, so we can calculate the area of anything by cutting the area into n number different parts, and then any ith section I have to find the generic area. That should be perfect. And then start converting delta theta into d theta, and you get it. Anyway, we'll see little bit more on it, then we will take another example. So this is the end of the story for the area and circumference computation through the repeated summation. Okay, we will see more on it. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.